Let's take a look at debugging R32V2020 code using SignalTap and the Memory Contents Editor. To use SignalTap to debug, go into Tools and then select SignalTap Logic Analyzer, and that'll pop up the SignalTap. If you want to look at particular signals, you set the signals you want to look at by double-clicking here. In this particular file, let's collapse it all down so we can take a look at what it looks like. It's got all the I/O pins, so you can select any of those, and it's got the RISC core itself with the peripherals. So if I want to debug, oftentimes I'll go into the CPU core part, scroll all the way down because it puts all the combinatorial stuff up higher, and then I'll select things that I want to look at. Like, for instance, if I want to look at the program counter, I'll select the program counter, and then I'll select the pre-Q, select the whole range of bits that I want to do, copy them over to here, hit insert. They're already in this project. When you go over, hit insert. After you hit insert, then you close. It puts them in the project. You can take them and they're in a long list. You can select that list and right click on it and select group, and then you can set the alias for PC. And if you want to see what's running, go up to after you've compiled and then downloaded. Of course, you have to set the path over here to the SOF file as well. You can compile from here, you can download from over here, and you can then go ahead and start capturing. So if I capture right now, it tells me that the PC is at 80, 81, 82, 80, 81, 82. And if I go over to the listing file for the assembly code, and I look at 80, 81, 82, it's in a tight loop here looking for the PS2 receive status. So that's a quick intro to how to debug using SignalTap. Probably find more details up on the web for how to use it, but basically you can find out where you're stuck in loops. You can monitor registers, monitor the program counter. One thing to note too is that over in the configuration for SignalTap, I set the clock to the CPU clock, and for the trigger I set it for reset being high. So if I want to go off from the start of the program, I press down the reset button on the card and then tell it to go trigger. Like, I'll do that right now. Tell it to go trigger, start it, it's catching the acquisition, and it starts up at 0, 1, 2, 3, 4. And you can see what, in this case, I've grouped together the R9 bits, but you could watch any register inside of the part and follow what's going on. It's a good way to debug. Also, looking at the memory contents editor through Tools and then In System Memory Content Editor will pop up the In System Memory Content. Sometimes you have to select the hardware and then scan the chain. And in this case, if I want to see what I've read in, I can select a particular memory that I want to look at. Got to select scan chain. Oh, already did. The memory that I want to look at, and then go down and press F5, and it will refresh the memory out of what was out there. And it went out and read the sector on the card and read back all A's. So it's working for the particular SD card I'm trying to debug. I was sending out blocks and reading back blocks. Obviously, I'm reading back a different block here than the one I'm sending out. I'm sending it out to block 1 and reading it out of block 0. But if I hit a key and then tell it to go again and come down and hit F5, hopefully I'll get back that set of numbers, and I am. So writing out this block to the SD card through a piece of the data RAM that I've created for read and write blocks, and then reading it back in this block, and I can see that what I wrote out got read back properly. So my code is working, at least some of it. I don't see all the data here. It looks like it's a little short. I'll have to go do some more debugging. Maybe it's only some fraction of it. Doesn't look like it got the whole thing. Anyway, good way to debug and good way to get visibility into what's inside the memories. You can look at the instruction memory from here. You can look at the stack and see how much the stack got filled up along the way. Not a whole lot of the stack is being used by this particular program. You can look at the first data space, and over there you can see all the strings that are in this code, and then maybe if there's any other data you can see it there as well. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.